Hello everyone, I hope my connection is good enough to support this live. Let's see if you guys can see me. So I'm doing an update tonight in place of Ikaika, who is traveling off island. And the big news tonight has been the meeting in Volcano Village. Essentially, the USGS, in combination with Civil Defense and the County Hawaii, have held a public meeting tonight at the Cooper Center in Volcano Village, discussing the hazards of the summit and also what's happening down on the Rift Zone. Well, I'm glad to see you guys actually can see me. I've been struggling with my connection for over an hour and a half now, so I'm sorry it's taken me so long. Hopefully you guys can hear me just fine. I've driven over to get better reception and share with you guys what I know about tonight. So, okay, the first thing and probably the last thing we'll talk about it again is the meeting in Volcano that everyone is talking about tonight. The USGS has just released on our website a new paper kind of summarizing the happenings at the summit with the caldera collapse, as well as the potential outlook and the hazards they might think might be present over there. So that's what we'll talk about first and last. Yeah. So what's making my phone ring a lot tonight is that Tina O'Neill, the scientist in charge at the Volcano Observatory, said that there was a small but real chance of explosions at the summit that might generate, the term is actually pyroclastic surges that could affect up to potentially 3 miles from the source, right? That's what the paper actually says. All right, yeah, glad to hear you guys can hear me, and thanks. I'm glad my connection is working. You guys seem to be seeing me and not complaining, so it must be all good. So, all right, so well, the first thing I was going to start off saying is that John Stallman and I have been talking about this possibility for a while already. Yeah, that what happens at the summit is that the collapses occur. That at some point the groundwater can come in. We all thought that might have been a lot sooner in this eruption, but we've recently said that it might have had a delay of 2 or 3 months. 2 months from the beginning of the eruption might, would put it around now, but there's no actual change in the eruption at the summit that we can see that wouldn't lead us to indicate anything like that's going to happen anytime soon. It's more that the USGS is trying to make this public knowledge, right? That everyone is really prepared for the hazards that exist with living at the summit. We've known that summit does collapse and can put up big ash explosions. So, yeah, that can happen. And in particular, as far as base surge, the first thing I want to say is that there's a big difference between pyroclastic base surge and all other kinds of surges as with pyroclastic flows. Pyroclastic flows are kind of the extreme. It's when you have essentially both flows are a flow of hot gas and rocks that are kind of suspended within the gas as it flows downhill. With a pyroclastic flow, you have more rocks. You have more rocks in the surges, right? So it's kind of a heavier flow. So it can go a long way down a valley, for example, right? It can travel, I don't know, tens of miles, that kind of thing, right? Down of a topographic valley, something like that. That's what a pyroclastic flow does, and it has all kinds of phenomena that are associated with its flow on the edges of the valley and all of that. But that doesn't really matter to us because we don't have those flows that travel those huge distances. The most recent data from Kīlauea of the base surge is that was the eruption of 1790. There's a famous story of Kamehameha's cousin, Kīlauea, leading his army to engage Kamehameha in battle and stopping at Kīlauea caldera. And during his visit, his march by, there was explosive events at the summit. And the story is that he divided his army into 3 groups, and these groups were spaced out some distance apart, maybe half-mile apart, between a first, second, and third group. So I'm not sure exactly how far, but there was some distance between them. And of those 3 groups, there was one surge that came down and wiped out the middle group, and the groups on either side were actually all right. Still, I mean, it shows how deadly this can be. I think to date that makes it the deadliest event in Kilauea's history, and perhaps in volcanic history in the whole United States. Now that Kīlauea is part of the U.S., even though that wasn't at the time, that may be the deadliest eruption that is in today's United States to date. Is that base surge from 1790 that killed that 1/3 of Kiowa's army. So in that particular event, we think that that surge went to the north, kind of over the area where the Jagger Museum is, down kind of towards the, more or less, somewhere between there and KMC area, down towards the highway, more or less, right? So that would be the direction that the last one went. And the last one, I think, relatively speaking, that one was one of the smaller ones. The bigger ones actually went to the south and to the west, out of the, kind of within the caldera, but kind of out the southwest gap of the caldera where it's lowest. Surges don't always follow the lowest spots. They can kind of flow down and out and kind of over the crater wall. Maybe what'll help is, I got my iPad set up here, so I'm gonna switch my camera and show you guys a picture I found online of what one of these ash explosions might actually look like. Okay, so all right, so when you have this big ash explosion, and in this case, we're thinking on Kīlauea in the past, these have been driven at least somewhat by steam, maybe fresh magmatic gases as well, although right now the magma is dropping away, so we don't have any magmatic gases really coming to the party. Now that possibly could change. We can talk about that shortly, but essentially, once the thing is projected up into the air, there's a whole bunch of ash and rocks kind of coming up, and some part of that's going to come back. The heaviest part is going to come back down the outside, and then hit the ground and start flowing outwards from the base, right? This is the base surge right here, is this part right here, right? Don Swanson did a lot of work with this, looking at what Hawaiian chants, and Hawaiians describe this as there being a small hill with a big hill above it, during these explosions, right? And maybe hill isn't the proper translation, but there's this big mass of rock right here. The lower one and an upper one is basically a shape of this, right? So the Hawaiians have observed this and have recorded it in their chants as warning for the rest of us. So the danger is very real from these things, right? The USGS has been acting liberally, right, as they well should, to prepare for the potentially the most surprising thing that might actually happen to us, right? So let me kind of switch my display here in my iPad. Give me just a second. And here, I'll switch my camera again. All right. So, well, first let me show you guys this. All right. So on the HVO web page, here it is, the front page. If you just go to hvo.wr.usgs.gov, it'll forward you to this volcanoes page. And then right here, there's a section called HVO News, right? And you'll see they just updated this today, July 5th. So I'll go down over here to the side and click Read More. And that brings up this paper that they just published, right? And thanks a lot to John for helping me out when my internet connection was bad to get all this lined up. So that's the paper, and there's a lot of detail in here. It might be something for everyone to read, but if you want to know more and in great detail exactly what they say, this is the place to find it, right? This kind of summarizes what they said in the meeting. So today's meeting at the Cooper Center was basically an announcement of the information of what they put out in this publication, right? And yeah, so we'll get the kind of, I know it sounds scary, put out the scary part first as far as the range of this thing. Okay. This is maybe the most relevant thing. This is actually an image that Don Swanson has shown before at almost every single one of his talks that he presents as far as the 1790 eruption, right? So if anyone has been following Don for the last, well, he's probably been showing this for the last 5 years at least, right? And this is the hazard map that he's showing, right? So with the source of the explosions being right here in the middle, the ash cloud presumably rising from there, right? So the 1790 event put ash like in this direction over here towards the campground, and then also to the south and west, kind of out this gap over here. Kind of, in this case, it was a downwind direction that we're used to, the trade winds blowing. All right, so they've been very conservative and said, okay, the farthest one reached over here, and let's say that something crazy happens and like we have a flow that's not following topography, and as the wind direction is not affecting it, whatever else, then maybe it could go all the way in this particular, on this radius, all the way around to there. Right, so that's the most conservative hazard they can actually draw. And of course, notably noted in there is the golf course is actually quite close. You see it's not very far from the edge of the inner caldera of Kīlauea. Right, and then the volcano village a little farther out, but still within this 3-mile radius that's drawn. Right, so the chance of this is happening is actually very, very low. But this is something that has happened before, and the USGS wants people to actually be aware that this can happen. So it's not, you know, a huge, you know, huge surprise that this kind of thing actually can happen. They're not predicting this to happen anytime soon. There would be some big changes in a volcano monitoring data before something like that were to happen. But that's basically what they're talking about, right? Is the threat of those ash clouds that are rising, then collapsing back down and flowing sideways. Right, and you know, when it does flow sideways, if anyone is within that 3-mile radius, or in a direction that it's, oh, you guys lost me. Okay, let's see. Maybe I'll wait till you guys comment that you can see me again, perhaps. Let's see. I'm back. Okay, good. Okay, when I switch this bad on a signal, okay, maybe it's because I'm having to point the camera down at the iPad and it's not catching the signal as well over there, so I won't do that too much again then. I'll keep it this way. All right, so what I was saying is that they've drawn that radius, you know, with the largest possible impact, you know, if things were to go the absolute wrong way, let's say flow in a direction that we don't expect it and go as far as the farthest ones that have gone, then it might be able to go into that area of the golf course and the village, right? So, but that's not something that's going to happen before we see the build up to one of these big explosion events, right? So, as far as the explosions themselves, to me, the most likely cause still, you know, just based on our previous thinking, and of course, maybe that's not the smartest thing because we're not exactly sure what's going to happen, but you know, the thing we've known about how it can happen before is the steam explosions, right? So we've mentioned in our last couple updates that we think that Don Swanson mentioned at the last meeting about a week ago that the groundwater might take a while to actually reach the area where it might generate the steam to build up enough pressure to cause steam explosions. So that's still on the table as far as happening in the future. So that's one way that it could happen. And so we mentioned that it's not quite clear to me. We mentioned 2 months from the beginning of the eruption is around now. So potentially now we might be coming into that phase, but there's no detected signal that shows anything like that happening. It could also take, you know, 2 months from when this thing maybe really got going and the cracks really shaped themselves to really reshape that inner part of the conduit that's now collapsed. You know, it may be that it's still 2 months from now. I definitely don't know because I haven't seen their models myself. I'm just going off of what Don said, but that's definitely a possibility. One other thing that they brought up is that there's a chance that if like there's a big earthquake that somehow disrupts that pile of rubble and then somehow makes it easier for the magma that's still down there and hasn't drained away yet and is not draining away yet to actually come up, that it might make use of a pathway up. And if that were to happen, then we would see again a pattern of earthquakes that kind of precede a fissure event. But fissure event could happen at the summit at some point. And in fact, you know, over the history of the volcano, it's, you know, they've happened there more so than anywhere else, right? So in fact, that's why the national park is kind of built around the summit, is because it's a great place to have safeguard against development and for that impact as well, you know. So the park kind of serves two purposes today. One is visitation, but the other is to kind of prevent anything else from being there, right, in the path of that devastation, you know, give nature its space to change as it needs to, right? So that's basically it. So I think in Tina's segment of her talk, she mentioned that there could be, you know, that there was a, you know, well, essentially comes down to this, that for the next 2 months, their forecast, their prediction, as good as they can have one, is that things will continue as they are right now, right? Maybe the same pattern of collapsing and the crater dropping inwards more and more and more, with earthquakes in a magnitude of 5 range every day, more or less every day or so. So that pattern is expected to continue. Beyond 2 months, they're not as sure. They just don't know what might change in that time. They don't know how it's going to interact with the rift zone. They don't know if it's going to precede the rift zone eruption ending or follow it afterwards, right? That's a big question. We don't know if it's going to have explosions at the tail end of the eruption, or if it can peter off then before the next activity begins, however long it is from now, whether it's years or, you know, however long away it is. That we might have explosions at that point coming up as well. But certainly, you know, we know the summit does have explosions, right? We've been talking about this for a while. So they're basically just saying, okay, you know, the summit explosions do happen. They may still be happening in the future, you know, and everyone be aware of that, because when we see the signals for an eruption happening, like an eruption, they'll put out the word that that's going on. And people will know what they're talking about and not be like, oh, what's going on? Or this can happen here, or what do you mean? Or so they want people to have that same level of preparation up here in a volcano area, and I would say especially in a golf course and in a part of the village that's closest to the summit crater as well, to have thought about the possibility of that happening, you know, if they start feeling extra earthquakes, you know, which would, you know, just like now, we have a lot more earthquakes before a big event, right? So if you see more earthquakes and the events are getting bigger or they're changing in character, right? Let's say that we see a whole bunch more steam coming out of there. Steam starting and then steam stopping and then steam starting and steam stopping. That would be a big cause for concern as far as, oh, something's changing, and maybe we'll have some different kinds of explosions, right? So, just to repeat, I know, okay, so let's see, I got some people who have just kind of joined now. Well, I had shown a picture of a base surge. You might have to rewatch it to see that, because every time I move my camera, I seem to lose signal, right? So I'm not going to move the camera anymore. But earlier in the broadcast, I showed a picture of what a base surge actually looks like. What happens is the explosion of gas goes up, carries the ash upwards, and then along the edges, ash falls back down. The heaviest ash falls down along the edge and then kind of fans out to the side, right? And when it hits the ground and fans to the side, it can go really fast, right? That's where the hurricane force winds comes from. So we know this has happened on Kīlauea before, most recently in 1790, right? The story of Kīlauea's warriors that were defeated by the volcano, you know, en route to fight Kamehameha, essentially. That's kind of how I think about it, you know, that really changed Hawaiian history. Was actually one of those base surges, right? And it was kind of directed and it killed off the middle third of Kīlauea's army, right? So in that case, it was very directed. These flows can go in any direction from the summit. But they only happen after the explosion, right? So the explosion happens, the ash got to go up. It's got to go up enough for it to start falling back down, and then it's going to come down and go sideways, right? Once it starts flowing sideways, it can flow really fast, right? Hurricane force. So that's kind of what the hazard actually is, right? And this is very different, okay? So, I mean, one thing that's very confusing, commonly confused among people all over the world all the time, is this difference between a pyroclastic surge and a pyroclastic flow, right? They both have the word pyroclastic in it, which makes it very, very similar. But a pyroclastic flow is actually a much denser current of rock that flows, and it usually comes out of a stratovolcano explosion, right? So an explosion like from somewhere like St. Helens. And the difference, really, to me, the way I think of it, is that in an eruption like St. Helens, the lava is basically sprayed outwards. So a lot of that ash isn't just the rock that's been pulverized. It's actually like tiny little droplets of lava that are getting sprayed out with such force, and they're freezing on the way up in tiny, tiny little sizes. and that produces a lot of the force and the heat and the energy for that really huge billowing ash explosion. So in those kind of eruptions, a lot of the lava becomes that ash, right? Whereas with our eruption, not that much of the lava becomes ash. Basically, the explosion is pulverizing the rock above it, and that's where the ash is coming from, right? Sometimes you do have some magma spray coming in there, but it's not nearly as much what you have out of St. Helens, because the magma at St. Helens is basically stickier, thicker, it's more viscous, right? The gases can't escape as easily, so you can build more pressure, and therefore when it blows, it really blows, right? So that's what a pyroclastic flow is, and we don't get pyroclastic flows exactly here. We get the pyroclastic surges. And the surges are different in the sense where they're more gassy, so that makes them be able to kind of almost like float more, right? One thing that that comes to mind when I think of like a base surge is like when I open a bag of concrete and I pour it out, right? And there's always that dust that kind of comes down and it flows around the ground, like, away from a pile of concrete or, your bucket or wheelbarrow, wherever you're mixing your thing. There's always like a light layer of dust that kind of just flows down and kind of out along the ground. Like that's essentially like the base surge equivalent of the eruption. Like a whole bunch of dust is falling, and then some of it kind of gets organized in a flow that flows down and out to the side. And would be the size of ants in that analogy, right? That's the whole issue there, is the scale of the thing. So yeah, the base surges, they can still travel very fast. They can go over boundaries like the edge of the crater. Although in 1790, the biggest ones did go south and to the south and west, which is the direction the Kīlauea caldera is the lowest edge is in the south and west. So it did kind of flow out that direction. So the plot that I'm not going to show you guys, I believe, is showing that their area of concern is 5 kilometers, 3 miles, right? So not just the area to the south and west. They're being extra conservative and saying, okay, well, the farthest distance we've seen it travel in the past, even if it went out the low side, let's assume that it can go out the highest side, which is the side towards Volcano Village. And let's say that we have, the biggest possible ash explosion that would do that. Then they basically draw a circle around a hazard area that includes Volcano Village. The golf course is closer. The golf course is included in almost every hazard of Kīlauea's caldera, because it really is so close to the caldera. And that's not a big change there, right? So kind of to reiterate, they're not expecting anything different for the next 2 months, but they want people to be aware of this possibility that this kind of eruption does happen. It has happened, and they're thinking seriously about the possibility of it. So yeah, everyone should think about it, because if you're living at the summit of Kīlauea, this is a reality of living here, right? Is that you have to deal with explosions and earthquakes and ashfall, right? And it may be that it's a very different Kīlauea than we thought we were moving on to or living on. But that's the reality of Kīlauea really over geologic time, and maybe we were living in a little calm period, right? I remember being able to walk out to the Halemaumau Overlook before it was closed off in 2008, right? And we'd stand there and see all those big boulders everywhere and all these giant dunes of ash everywhere. And if you were like me, you'd notice those and say, well, where did those come from? And it was clearly from these kind of events happening before. So I think okay, hold on, let me scroll back and try to get some of you guys' questions. Can you outrun a surge? No, probably not. Probably the most relevant thing to explain with that and explain how it actually goes is the story of Kīlauea. When Kīlauea's army was impacted, a third of his army was killed by the eruption in 1790. They described that people were kind of holding on to each other in embrace, right? And they actually were not burned. They were kind of maybe singed a little bit, but they weren't really burned. So like, the ash cloud wasn't really that hot, right? It was probably suffocating, right? There was probably so much ash that there was no air in there for anyone to breathe, right? That's basically what it came down to. And, hurricane force is, that's just talking about how fast those things are the ash is flying by, right? Sideways, like something like 70 miles an hour. So that's a relevant part of the conversation. There's nothing happening in Mauna Loa. There's nothing happening in Loihi. I'm not sure about tsunami in 1790. I will talk about the fissure shortly. It's just me doing the update tonight. Ikaika is traveling right now, so for the next few days you guys will probably be hearing me more so than him. So maybe I'll switch to the little bit I know about the fissure right now. So let me see if I can get my iPad up here so I don't have to move my phone down, so I can show you guys at least one picture of what is happening down at the fissure. All right, let's give it a shot. Sure, hold on. Bear with me just a minute while I get this. Try to get this set up here in such a way that it's useful. Okay. Let's see. I'm gonna try to switch the camera, but I'm not gonna move the phone. Let's see if my signal stays. All right, we'll give it a test. Well, the glare is not very good, but okay, that's pretty good. So can you guys still hear me and my connection's still there? It seems like I am not getting a warning on my phone, so I'm assuming everything's good. All right. So this is a picture through the rain from Scott Wilson once again, showing the fissure or the river down in a Four Corners area this evening. So what you can see is there's a big bend. That really bright spot is that kind of little lava falls where it's falling from that, where it kind of diverted around, and it's actually back in an old channel. I don't know if I can use my finger to point. Let me see if I can get my finger a little higher up here. Oh, there it is, right? So, okay, there's that bright spot right there. There's the river. It had been going along kind of straight across, straight across this way, like that, and it kind of went down and around. And it seems to be refilling the old channel, right? At least this upper part of it. And down here, it seems to be feeding a new flow front kind of on top of the old one, right? So it's basically staying, you know, even though it jumped out of its bank earlier or maybe diverted slightly, it seems to be back in the channel and refilling it, at least that upper part. And the channel maybe is not as well established and defined farther from here. So maybe that's why it's kind of spreading out over top of this most recent flow, the one before today. That's all red, obviously. So that's basically the Rift Zone update, well, the Four Corners update version of the update. We've noticed on a webcam that, let me turn the camera back around. Just get my other hand back. So we've noticed in a webcam that the fissure heights, the fountain heights from fissure 8 are not huge, but they've been going down for a while, so we're kind of looking into that. But it seems like there's, as far as we can tell from the information that I have, the flow hasn't really changed that much. It did seem kind of strange that the flow kind of jumped its banks, and the channel drained, and then the flow is reoccupying. So I'm not really sure the dynamics in there, if that might mean anything about if there was any change in the flow volume. For now, I'm basically not, assuming there wasn't, unless I hear something that leads me to believe otherwise. I think it was just basically rearranging itself over there, but it's basically back where it was before, which is what everyone really wanted. All right, so we've heard that fissure 22, probably 22, has been was reported to have kind of paused earlier this morning, maybe overnight last night by USGS, but it seems like it's actually reactivated. So we've had someone on Hawaii Tracker talk about how they've seen it spattering quite high, where it could be seen, all the way from the Y. So I think 22 is probably weekly active again, but fissure 8 is still the one that's really going, right? And as far as it's concerned, it's basically back in its channel and flowing back towards the ocean. Speaking of the ocean, because that main channel seemed to drain, it seems like the ocean entry is still shifting to the north. It may actually be mostly to the north now. So we're waiting to see if there's going to be a little drop in the ocean entry that corresponds to the kind of draining of that lower segment of the river. So that'll be interesting to see how the ocean entry changes further beyond that, given the changes in that lowest part of the lava channel. But essentially, it's back in its channel from the pictures that we can see. I'll show you guys a picture again. All right, so through the rain, there it is. Even though we have a bigger S-band bend right in there, not really bright spots where the lava, where that diverted bend is pouring back into the old channel and reoccupying it, and then feeding a new flow front that's kind of widening down here where the channel is maybe not as well established. So we'll wait and see what happens with that. Down over here is the kind of surge that was coming through the middle of the flow, right? Kind of that same pancaking action we were describing before. So that's where the main ocean entry has been, kind of on the northern edge of the flow field. But we'll see if there's still connection between this part and this new flow that's coming down the briefly emptied channel that's now been reoccupied. So that'll be interesting to see how that reconnects, or whether this leads to a new ocean entry right above. So that's the brief summary for that lowest part of the channel. The question: can this happen, and why? This is probably very similar to so it's the short answer is it could. It seems like maybe it's not as likely. It's the edges there seem to be more stable, whereas right here by this green mountain area is where the flow actually spread out when it was first coming around. So that's kind of a much flatter area where we've had a lot more dynamic situation with the shape of the flow and where it's going. But this is exactly why we're worried about the places where these channels the channel takes the biggest bends, right? Because right there by Green Mountain is where it had essentially a 90-degree turn, and it's not surprising that right there is where it actually made its change. So yeah, for those of you who just recently joined, Ikaika is traveling for the next few days, so I'll fill in as much as I can, and we're in contact almost all the time. So he'll let me know if there's something I need to relate to you guys as well. So yeah, let me see what other questions. The glow in the sky. I'm not sure. I'm not down in Lower Puna tonight, so I'm not sure. Where I am, it's pretty rainy, so I can't see much from here. But it could be just the way the clouds are, right? Either there's clouds blocking it, or there's not enough clouds to reflect it. Is basically what it will come down to. All right, so we started off talking about the summit. We probably need to talk about that again. That seems to be the hot topic of the day, right? Is that everyone is worried about what was said at the USGS meeting up in Volcano. And essentially, it kind of comes, just to reiterate, it comes down to the paper they've just released on their website, kind of summarizing the hazards that have occurred so far and their outlook. And their quick outlook is that within the next 2 months, they expect no change. Right, they expect things to continue as the way they are now, to continue collapsing, and essentially this fairly well-defined cycle pattern of earthquakes building up to big collapse events in the more or less magnitude 5 range. But they have also outlined that there are possibilities of more serious changes happening at the summit. Serious in the sense where it could actually start impacting people and residences within a 3-mile radius of Halemaumau, right? And this is kind of derived from the fact that there could potentially be what's technically called a pyroclastic base surge, right? I've described earlier, it's not exactly a pyroclastic flow. It's not really the same thing. So the range of impact is not nearly as great as a pyroclastic flow. But it has happened here in the past. It happened in 1790 to the warriors of Kīlauea who were fighting, actually on their way to fight Kamehameha. So it has happened. That still makes it the deadliest eruption in today's United States. So the USGS basically was outlining that. They're saying as well, that previous summit collapses have had other events that kind of associate with them, such as high lava fountains, right? Lava fountains like the one that we had at Kīlauea in 1959, the ones that shot in the air on the order of 1,800, 1,900 feet, 580 meters, for those of you working in metric. So people who live in a golf course know that there is a really thick layer of reticulite, right? Reticulite is that really kind of foamy rock. That's our Hawaiian version of pumice, you know, is the way I think of it. Can get up to be 98% airspace within what's technically a rock. So there is maybe like a foot of it in the golf course, right? Because it's possible that when the caldera is collapsing, that some cracks could form that allow magma to move from wherever it actually still is and hasn't drained away down on the summit, up through some new pathway towards the surface for an eruption that would begin with a fissure, could cause a high fountain. But just like the fissures in Lower Puna, those would have clear signals that indicate that would be happening. A whole bunch of earthquakes, a whole bunch of increase in gas emissions, all that kind of stuff. So none of that is happening now. They're basically just saying that they're now really paying attention to that as a possibility of something that could still happen with this eruption. Especially if we have the delay in a steam reaching that old part of the magma conduit, the groundwater, I mean, reaching that old part of the conduit where it can become steam and drive steam explosions. Right, so that's basically the gist of it. So deadliest eruption in the United States, how many people died? That's hotly debated, but the lowest range is 80 people. Right, it's not clear if it was 80 people altogether. I've seen estimates that go up to 8,000, and it's really hard to say. So we'll say 80 was how many people were actually minimum killed during that eruption in 1790, right? The 1500 one, so yeah, the 1500 one was probably a little bit bigger than 1790, so that's probably why they're being extra careful, not knowing how far this thing is going to go. Someone brought up Pompeii. Pompeii is the different kind of volcano. Vesuvius, right? Pompeii is a town that was destroyed. Vesuvius is a volcano, and that's the kind of volcano that is the more that puts out more of the lava spray, which was describing before, right? And the eruption is it's an explosive eruption essentially. Even though explosions happen in Kīlauea, you know, they're not always explosive eruptions. You know, I mean, I'm probably splitting hairs for most of you guys, like, you know, drawing a line on what I call an eruption and what I don't. But essentially, you know, in our volcano, the ash is coming from pulverized rock, and maybe a tiny, tiny amount of it's coming from the magma itself. Or somewhere like Vesuvius, you know, a lot of the magma is actually becoming the ash, so you have a lot more volume of rock, whether it's an ash size or what other, you know, larger sizes in the air at the same time, which means it can actually flow in lots of different ways. It can separate itself and go a lot farther. Than the surges, essentially, right? So not like Pompeii. I mean, similar in a way where it's, you know, an ash flow, but it's not the same scale as what happens in Pompeii. Someone's watching my right eyebrow. That's amusing. Yeah, it's interesting how they go on the opposite ones. Yeah. So, all right, guys. I think I've probably talked it over maybe 3 times over now. So, oh yeah, the last thing that happened was the sinkholes on Highway 11. Okay, so the sinkhole in Highway 11. For those who don't know, Highway 11 right now is down to 1 lane around the golf course turnoff. I believe the Kau-bound lane on a shoulder, there was a hole that opened up that's maybe 5 feet across and 30 feet, 20 to 30 feet deep. So that's part of an old crack that's a part of the caldera fault system. So that crack hasn't been there before. And essentially the crack has widened by the movement of the volcano. And as the crack widened, the material that they had put in the crack before to put the road over it is kind of sunken in and kind of fallen down into the new space. And they actually put in more material and refixed it earlier, maybe yesterday. And then since then it's reopened, more stuff has fallen in even more. So it is dangerous in the sense that the crack does go across the whole road, right? and that's why they're on site, to make sure if it keeps opening and more holes open up, no one's going to drive into one. That's basically the hazard there, right? So yeah, that thing is clearly still moving between yesterday and today, so I'm not sure how quickly they're going to fix that. It's probably going to stay dangerous there for at least a couple of days, I would guess. Best route to escape from what? So I guess what we've been talking mostly about is the base surges, right? How they're not pyroclastic flows, that they're base surges instead, you know, that they're still quite dangerous, that they have, you know, extended up to 3 miles away from the Halemaumau event, right? So they would be preceded by by a bigger explosion that would put up a huge amount of ash, you know, by whatever cause that we've kind of detailed already, that was put out in the USGS paper that everyone can find on the front page of their website, and look in detail at what they're talking about in there. They try to make it accessible for everybody, so everyone can kind of read for themselves what's going on there. So, you know, I'm not sure. I think, you know, if I lived in a golf course, you know, if I saw that these kind of events were starting to occur, I would probably find somewhere else to stay myself, personally. I'm not as sure about Volcano Village, but, you know, it may not be a bad idea for those parts of the village that are closest to the caldera as well. But right now, just to reiterate, we're not seeing any of those signals. There's no imminent threat of that kind of thing happening. You know, what's expected is for the next 2 months for it to basically be doing the same thing as now. Nothing is going on with Mauna Loa still, or any of the other volcanoes, so we'll just we're not going to talk about those anymore. And yeah, so at the meeting, they say towards Hilo. Yeah, that seems a pretty good direction. That's where most of the stuff is, right? Is towards Hilo. So if you're going to evacuate towards Hilo, it's probably not a bad idea. Although if you're, you know, down Pahala direction, then go the other way for sure, right? Okay, well, you guys are trying to find a report. Okay, so I'll just tell you where to find a report, and then I'm going to sign off. If you go to the home page of the Volcano Observatory, so if you type HVO USGS like in your search bar, and, you know, click the link for the main home page, then there's a map on the upper left part of the page, and just below that there's a section that says News, and that first top item should be the paper that is being referred to at the meeting tonight. All right. Well, thanks, guys. I'm not going to repeat it anymore. I'll let it stand on its own, and just try to reassure you guys there's nothing imminent about to happen, right? You know, everyone. You know, the basic point is everyone should understand that this volcano does produce this kind of activity, right? It is possible, and people should be prepared for the eventuality of it happening. Know the USGS is watching for all those signs that would indicate any kind of change leading toward that. I have not seen those changes yet, right? But they're watching for them very closely, of course. You know, they care about it, you know, about all of us just as much as we do. So they're doing everything they possibly can. I'm sure of it. So, all right, guys. Good night, everybody. And yeah, we'll put out another update tomorrow. Yeah, for sure. So I'll keep doing my updates. Even in place of Ikaika whenever he can. I'm sure he'll do whatever he can from remote, but we'll keep passing information we know to you guys, right? So the basic I suppose theme of today is, you know, be prepared, but you can stay calm for now, as far as, you know, the world's not going to end tonight. All right? Okay, mahalo, and stay classy, everybody.